Okay, let's get started. So, okay, you know what I come here all the time is I'm on a mission, okay? So, we have a question here, question 3, 4, and 5. Okay, so question 1 is very, very easy. Before I get started, let me show you something quick. I can read for you here. They say the area of a triangle ABC, x centimeter square, and the area of XY area, not area of triangle XYZ is y centimeter square. I mean, this is the area, so we don't know. It could be 10 centimeters square, 20 centimeters square, so we don't know. Even for the other area, which is XYZ triangle, we don't know the area. But now, which is the following statement of inequality represent the statement which is true? So we want to pick out of this to see which among these is going to represent this statement, which is they say area of a triangle ABC is at least the same. Okay, so the trick here is they want you to tell us like how to understand the inequality. Let me explain to you quick about inequality on how to know whether it's at least, at most, maximum, minimum. Look here. When you say, if somebody say for you to watch this video here, you need at least 1 gig. What does that mean? Meaning, okay, for you to watch this video right now, you need to have an internet, see, of 1 gig, at least 1 gig. Meaning either you have to have a 1 gig, 2 gig, it has to be not less than 1 gig. So if somebody say at least, means start from that, whatever they mentioned, and above. So at least 1 means it has to be, whatever we say, it has to be either greater or equal to 1. See, because this is greater or equal. So that means at least than 10 means at least than 10. You see what I'm saying? So at least means it has to be whatever you have and more. At least you need to have a 3 pen to do all this video. Means it has to, it can be 3, 4, 5 and more. So at least means it has to start from wherever you have and more. Okay, so now we understand at least. So if somebody say at least, meaning, let me write here at least, meaning it has to be greater or more. No, I'm wrong. Okay. My apologies. Listen. So, now let me explain about this at least. Okay, let me explain about this at least. If somebody say, for example, for you to watch this video now, I'm explaining to you, you need to have internet, correct? Okay, so now for you to watch this video, you need to have at least 1 gig. What does that mean? Meaning, you need to have for you to watch the video, let's say this video, you need to have at least 1 gig. Means not less than 1 gig. To watch the video V, it has to be not less than 1 gigabyte. So that means at least. Oh, for me to solve this video, I need to have at least 3 pen. Means for me to solve, let's say solve is S, I need to have what? At least what? 3 pen. You understand? So at least means starting from what you have and above. So at least means start from what you have and above. That means at least. I apologize guys, there's a little noise in the background. I hope you can hear clear. So at least means start from what you have and above. But the common mention here, at least the same. Oh, so what does that mean when they say at least the same? At least the same is like, oh, for me to solve this, okay, for you to watch this, it has to be, for you to watch the video, it has to be at least, means exactly 1 gig and above. But when you say only at least, means it has to be more than 1 gig. Let me say it again. If you say the video must be at least 1 gig, means it can be 1.1 gig, 1.2 or 3 gig, and for me it must be more than 1 gig. But when you say at least is same, or you can say at least is equal, means it has to be even 1 gig exactly, you can watch the video. Means it can be 1 gig, 2 gig, 3 gig, you can watch my video. Do you understand what I'm saying? So you have to differentiate when they say at least and at least is same. So when they say at least, it's like, okay, let's say X is for you to come in a venue or in a video or in a cinema, you need to have at least, how much? Let's say this money. At least you need to have a $10 or 10 CD or 10 shillings for you to watch it. seen or whatever video. Okay? Oh, at least. But when you say at least is same, means it has to be 10 and above. Means it could be 10, it could be 10, 20, it could be 10. But when you say only at least 10, means it's not 10, it has to be 10 and something. More than 10. I hope it makes sense. Okay? So now let's come here. For this one, they did not just say at least, they say at least is same. Oh, so at least is same means it must have with that equal. You see, means the head of ABCD. So what is ABCD? ABCD represented by X, so we're going to say X is at least. So at least we know this. But they mention is same, so we know same means is equal. But if there was no this word same, and then I wasn't going to need this. It's the area of XYZ. But what is XYZ? XYZ represented by Y. So out of all these options, it's going to be option 1. You see? So that's what at least represent. What about at most? So at most is the reverse of this. When you say at most around, like for example at most, let me just catch up quick. At most means instead of saying that, you say this. But at most or equal, then it's going to be this. Which is going to be the same. This is at most or equal. Or it's equal, or you can say the same. And this at most is like at greatest, the same thing. At greatest means the same thing, or you could say at biggest, greatest or equal, at biggest. So if there's no word the same or, and then you can just say this. But when they say at greatest or same as or at biggest or same as, then you make sure you do that. But if they say at greatest, then don't just write there. At biggest, then just write that. Okay, now let's go to the question number 4. So let's say simplify. So this is more of the exponential simplification. So what I'm going to do first, I'm going to write my stuff here. Okay? A, 1/6, and then I got my B, -3, and then over X, -1, and then we have a Y. Out of both of these, power 3. And then here, we don't have no power here. So you're just going to stay in mind the same how it is. -2, B, -1, and then over A, 3/2, and then we have a Y, 1/3. It's very easy this one. Okay, so how you do this one? Look, first and foremost, I can expand and remove this bracket. Means this 3 is going to go for each one, because look, this bracket for each individual, for all of them. So also this is going to go for this power, and this is going to go for this power. Now we go. There's no power means this power 1. When there's no power, I show is power 1. Now let's multiply. A 1/6 times 3. Look, 1/6 times 3. When you simplify, it's going to be 1/2. So this is going to become A 1/2. So the top is going to become A 1/2. Now B -3 times 3 is going to give me -9. Look, you just say A 1/6 times 3. That's why you get A.5. Now we do the same thing. B -3 times this 3 is going to be -9. Now we come here, you say X -3 times -1 is going to be X -3. Now same here. There's no power means assume it's power 1. So 1 times 3 equal to 3. So Y power 3. So this is what we have here. Now you come here. There's nothing you can do because you don't have no power. So write it exactly. -2. B -1, and this is going to be A 3/2, and this is going to be Y 1/3. So now we go to the law of exponential. Okay, law of what? Exponential. So now what I'm going to do, I'm going to rearrange. I'll put them in a good order. Look, I can just literally, because there's no power here, I can just take this one and put it here, and then I can take this X and right here. See, but because of my space, so I can just take this one, plug in here. So this is going to become what? This one, this 3/2 is going to come in here, and this I'll write it in here. So here is going to be X -3, and this is going to become what? A 3/2. A 3/2. So it's A 3/2. You can write next line, right? Because of my space, that's why. And this is going to become X -3. I'll write X under X, B, everything I'm going to write under, similar thing. Okay, now I can just take this Y here close to it, means Y and Y. So this Y is going to come in here. Okay, B, okay. Okay, so it's not necessarily that much as long as I have a top and bottom, top and bottom. So we have a rule in exponential which says if I have, let's say, x power a times x power b, these are bases. You see this on the bottom, these are bases. When the bases are the same, only when the bases are the same, you say x, only write one base if they're the same. And then add this power. So this will become a plus b. That's the answer. You see what I'm saying? Only if the bases are the same. So if you look careful, this and this, if there's a multiplication, is like b times b, even if there's no sign, but mathematically there's a multiplication. So I can just say b power 9 times b power negative 1 because there's a multiplication between when you have a bracket. So that's same as say b power negative 9 times b power negative 1. So the bases are the same. I can just say b, and then let me add the power. Negative 9 plus negative 1 is going to give me negative 10. Oh, so now I'm not going to write this b again. Instead, me say b negative 10. Okay? So I can just say all this stuff is going to become, let me make a space here, b negative 10. So for all those b, they give me b negative 10 on top. Okay? Now, so this and this together, because there's a multiplication, it's going to give me what? b negative 10. But there's something I was supposed to start with a face. It's good to go alphabetical. That's the best way. Now, this one here, we have a rule in exponential which is say if I have, let's say this is k power 2, and then I have a k power, let's say 12, and this k power 10. You see now, the bases are the same. So when bases are the same, what you do, you write only one base. You don't have to write two. But for this case, remember, is division. It's not multiplication. So if division, you take, okay, look, how many, look, you can just do this, look. This is 12, right? So you can just say, okay, 12 means, make it similar, it's like 10 plus 2. It's like 10 and k power 2, same thing. You see what I'm saying? Because it was 12, so it's like k, base it was 1, 12, so I can just say k, 10k, so this and this can cancel, so it's going to be k power 2. You see what I'm saying? So, same here, it's like a and a half and a 3 over 2. So this, let me say, excuse me. So this, let me say, is a half, and here have a 3 over 2, a 3 over 2. But what is 3 over 2? 3 over 2 is like 1 plus a half. It's like, look, a half and a power 1 means a 3 over 2. It's like, look, base is the same, and when you add a half plus 1 is 3 over 2. So I write like this so that the top one can be similar with this. Can you see how easy that? So I can just say this, let me say a half, and this is going to be a 1 over 2, and this is a power 1. Look, this a half and half cancel. So I'm going to be left with 1 over a power 1. But a power 1 is like a. Oh, so if I cancel this and this, it's going to give me what? 1 over a. So it's like say 1 over a. And for b, I did already because it was same with this, and there's a multiplication. So I wrote one base, and then I add the top to give me b negative 10. Now, which one we go for? We go for x, yeah, x. A, B, and then X, Y. Okay, let's go for X. So our line is like this. Let's go for X. There's another way that you can do, but this could be the easy way. I want to make it easier for you, okay? There's the other one, minus the power, and you add the power. Okay, now let's go. So now let's go for what? For X. X and X. So there's a division here. So it's like X, negative 2, and then we have what? X, negative 3. But what is negative 3? Negative 3 is like negative 2 minus 1. Look, but I do that for a reason. So negative 3 is like negative 2 and x what? Negative 1 for a reason. You see what I'm saying? So it can be same with that. See? So you can just cancel it and say this and this cancel. So I'm going to be left at the bottom. This and this give me x negative 1 at the bottom. X negative 1 at the bottom. So now I'm left with only y. Okay. So this and this is like the multiplication here. So base, I'll write only one base because there's a multiplication. There's no top and bottom. And then one base, and then add the power. 3, look, y 3 plus 1 over 3 because the base are the same. So I only write 1 y, and then I add the power 3 plus 1 over 3. So this, let me say y 3 plus 1 over 3 is like say 3 1 over 3. But at this you can change like y 3 1 over 3 But you see this 3, 1 over 3 when you add them. But you can change this to improper. 3 times 3. Look, if somebody give you 1.5, this you can just, okay, let me take the same number. 3, 1 over 3. So when you multiply, then you add. So here you multiply to write as improper fraction, because as a power is not great to write as improper, is a mixed fraction. So it's better to write as improper. 3 times 3, 9 plus 1, 10 over 3. So see, I mean 3 times 3 equals to 9, 9 plus 10 over 3. So this will become what? 10 over 3. So all the expression we have been squeezed them and using the law of exponential, then it became that. So now let me explain further something a little here, very, very, very crucial, very, very important. Okay, if somebody give you, let's say this is x negative 4. Yeah, let's say you got that question. That's your final answer, let's say in some other question. We just imagine some other question. Never leave your final answer as a negative power. So what you do, you have to reciprocate. If there's no number, which numbers here we know there's a 1? It's like if somebody say k, k is like 1 times k. So what I'm going to do here, I'm going to reciprocate. What do you reciprocate? You only reciprocate a letter or a variable. But the rest of the stuff, leave them. So I'm going to write my 1 over, take this to the bottom, take everything to the bottom, x. Exactly the way you take to the bottom. But the only thing you change this sign. So this sign is going to become what? Positive. Oh, so it's going to become 1x positive 4. Oh, okay. We can do more example. Like if somebody give you, for example, let's say 2 over 3 y negative 5. Oh, we can do the same thing. So we have to reciprocate something. What is that we're going to reciprocate? Only this number with the power. So my 2 over 3 is going to remain the same. And all this is going to go to the bottom. So it's going to become positive y power positive 5. That's how you reciprocate. But not all the time it's going to be on top, go to the bottom. You only do that when your final answer is in a negative exponential. So, for example, if somebody give, let's say, 6x, or you can use any letter, let's say a negative 2. That's my final answer. After done my stuff, I left like that. I don't think it's good to leave like this, because your final answer should not be in a negative exponential. You know, that shows like you have not simplified to the maximum. So what I'm going to do, I'm going to say this and say, I have my 6, leave my 6, but this now is going to go to the top. You know, because it's at the bottom, so it's going to go to the top, so it's going to become a positive 2. You see, do you have to reciprocate this? No, you only do that when you have a power which is negative. And this we call it, this stuff I'm just showing you now, we call reciprocation. 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 You can just check in my other video, explain the whole topic by itself. Reciprocation. Or you can see reciprocate. So now, this is our final answer here, but I'm not going to leave my answer like that. This is unacceptable because these, they must be reciprocated. So I'm going to say, so then I'm going to say finally, 1 is just a 1. Now this is going to go to the bottom and this is going to go to the top, because it's negative, is going to go to the top to become positive, and this is going to go to the bottom, so it's going to be 1 over a. And then this is going to go to the bottom, it's going to be b power 10. And this is going to go to the top, it's going to be what? X power positive 1. And the y is going to remind where it is because it's positive power. See? So that's going to be my final answer. You see? But if you say 1 times k equal to k, 1 times pen, you don't have, I don't think it's good to say 1 pen. You can just say pen. Unless if there are 2, you can say 2 pen. I don't think it's good to say, how many, say 1 person. Come on, you can just say a person. So 1 x power 1, so this time I say just say x, because x power 1 is x. 1 times x, okay, this is going to become x power 1 is x. It's like 2 power 1, 2 power 1, 2. So it's like 1 times x equal to x over a b power 10 and then y 10 over 3. That's going to be the final answer. Let's go to the last question. The last question, oh, let me check first if it does record, because at the time I was just busy and then it was not recording. So, okay, cool. Now let's go to the last question. The last question is way easy. Okay, so last question, they said the interval notation. So this is not interval notation. What do they mean? Oh, but read careful. They say in the interval notation, the set of, so this set is not interval notation. This is set builder notation. So they give a set builder, and union means put together with another set builder is expressed as, so they say this, you can express as this, and then you can compress together and get something. So this set builder notation, it became interval notation, but this interval notation, you can still put them together and compress and get another interval notation. So they say in the interval notation of the set, this we know is set builder, is not interval, but what we're going to have to get. Now, let me tell you now how we're going to do that. So first, let's see if it's true that what they did to get here. And then I can show you the next so that you can have a clarity of understanding. So we know this is including, so it's like say -2 all the way to +5 excluding. So this is including because of this sign here. This is excluding because it doesn't have a equal. It's like, so -2 to 5, and then excluding we write this. Union. Now we come here, -3 excluding, -3 excluding. And then all the way to 7 excluding, 7 excluding. See? So you see, we have expressed this set builder notation to the interval, which can you see the same as this. So it's true what they say here. But now they want something they say equal to. So I don't think you can just leave like that. You can put them together still. Look, let's say for example, put your number line so you can understand clearly. If I have my number line like this, let's start for the first one. -2 to 5. What is -2? Including. -2, let's say it's here. Including, so you want to put like this. All the way to 5. Let's say this is 5. All the way to 5. But 5 is, okay, this is -2. Let's say this is -1. Let's say this is -2. -1, 0, 1. All the way to 5. Let's assume this is 5. 2, 3, 4, 5. 2, 3, 4, 5. Okay, so 5 is excluding. So excluding, you do this. Don't put anything inside. So they say the second one starts from -3 to 7. So this -2, -3 is going to be somewhere here, let's say. 7, all the way to 7. Okay. This -2, so -3 is going to be somewhere here, but it's excluding. It's like this. All the way to, okay. So this is what the first one represents. Let's do this. It's going to make a lot of sense because here's what is involved from -2 to 5. So you must bold it. Okay. So here, -3 to 7. -3, 7. 7. This is 5. 4, 5, 4, 5. My apologies. This was supposed to be 5. Okay, -3 to 7, 5, 6, 7, 7. But it's excluding. So it's going to be here. This is what they say. Okay. So now, what do they say here? They want to put this together as a union. What is union? Together. Union means what? Together. Okay. Now let's go. So for that case now, for the union. So we're going to say, so what is that if you union means you have to put them together. So if you put them together, it means it's going to start from -3 to 7. Because we put them together, you know? Because union means it's going to, so the answer is going to be -3 but excluding, all the way to 7, what? Excluding. And that's going to be our answer. So now, so we know it's going to start from -3 to 7. So if I had to pull this together, because together means you unite. You see, start from -3 all the way, because like you put them together. This is going to be our answer here. For A, this union this is our answer. So this is our final answer. Now let me challenge you now. This is not part of the question now I'm showing here, right? How if they ask for how if they ask for intersection, how if they put intersection here? So intersection, let me show you now. Where do they have something common? For intersection means they were supposed, look guys, this is not part of the question, right? It's to make you understand. For intersection means it just where do the intersection means where they have something common, which they start from. This here is where they have things in common. From here all the way to here. So I was going to say it start from -2, but including, because here is including, all the way to 5. But we have to exclude it because here is including, but here is excluding. So then it's going to be excluding, because for it to be including, both must be including. Like here is including, and here there is something. Here is empty, here is something. That's why I exclude here. If it was intersection, like if it was intersection here, but for this case, unfortunately, it was not intersection. So this is our answer of the question they asked. So subscribe if you first time here, share this video to other people, and leave a comment. I'm going to respond to your comments, okay? Leave a comment. Peace and love.